It is known that the sun has its own magnetic field. We can measure it now because we have the SDO, Solar Dynamic Observatory. And the amplitude and the spatial configuration of which this magnetosphere varies with time. And I mean, it's not like varies over millions of years. It changes every 11 years. It's quite spectacular. The formation and decay of these strong magnetic fields in the solar atmosphere results in changes of electromagnetic radiation from the sun, of the intensity of the plasma flows coming from the sun, and the number of sunspots in the sun's surface. Do tell. You mean the sun actually has influence over the weather of the earth? But wait. I thought rich people, I thought people that drove, SUVs and Escalades and expeditions, I thought the people that had cows, they were the one that was heating the world up. No, sadly, as it turns out, it's the sun. It's the sun. Sorry, it's the sun. And last time I checked, unless our consciousness is involved, I don't think we have any influence over the sun. You see, the sun goes through these cycles, and solar scientists look at the sunspots on the sun just like we do. If you have a nice coronadoscope, you can see it, or if you have a solar pair of binoculars, I have a pair. And if you look at the sun, you can notice the sunspots. But it doesn't take very long to notice that the sunspots can appear equatorially, which are kind of benign and don't really have a lot of effect on whether the sun is changing its magnetic fields. But the ones that are very high latitude, the ones that are way up north, way down south, away from the equator of the sun, those are the ones that signal that we're getting ready to change the magnetic field, the pole shift of the sun. And this is what ushers in a new solar era, which we call them solar cycles. And we've been in solar cycle 24 for a long time, since 2012. And now we're getting ready to flip, right? Because it's 2012, 2023. Hey, that's 11 years, right? The study of changes in the number of sunspots reveals this 11-year cyclic structure. And it definitely affects the Earth's environment. Now, they've made their hay, have they not? I mean, they've played their 11-year deck of cards, have they not? They moved some money around. They made some people migrate, right? They set up some taxes and they made you afraid. And now your kids have anxiety over it. Oh, because they're only 11, so it's perfect. It's perfect. Perfect. And the analysis of carbon-14 and, of course, beryllium-10 and other isotopes in the deep glaciers when they core drill them and they pull them up, and in trees that they cut down, they can go look at the rings in the trees and they can look at these elements that decay fairly steady. That I say fairly with a small f because the rate of decay does change depending on how much cosmic radiation the Earth is exposed to, how much galactic forces work on the Earth. It can change. Likewise, if you probably have a nuclear explosion or something like that, that's going to change the rate of decay as well. But what happens is these elements, when they're consumed by something like a tree or an animal that dies or a sedimentary layer, is that element then goes into stasis because it's not chemically being altered at that point. It's not being breathed. It's not being chemically changed. The carbon or the beryllium in them begins to decay. That is to say, neutrons begin coming off of it. It begins to lose weight at a steady rate. And carbon-14 gets down to carbon-12, right? Which that's the normal molecular weight, but it's gradual. And what they could do is they could look at the ratio of carbon-14 to the rest of the carbon, and that's how they can tell how old or how long that deposit's been sitting there. It's a rough estimate. I mean, you can carbon date a snail and say, oh, this thing's 20,000 years old. There are several cycles with different periods and properties, and the 11-year cycle, and then there's a 90-year cycle. They're the best known of them because humans have been able to measure them for a couple generations now, and we have better and better instruments as the age goes on. So the 11-year cycle appears as a cyclic reduction in sunspots every 11 years, called a solar minimum. And the 90-year variation is associated with periodic reduction in the number of spots in the 11-year cycle from 50% to about 25%. And in the 17th century, because we really only have one example of this, and that's not really a trend now, is it? But it is an example. And we did make an observation, and a direct observation is a fact, so we're using it. There was this what was noticed was there was very prolonged period of solar activity. And you know it as the Maunder minimum, okay? And it lasted from the mid 1600s to about 1700. And during this period, there were only about 50 sunspots instead of the usual 40 to 50,000 sunspots. I mean, talk about a blank sun. It was like the end of days. And the analysis of solar radiation showed that its maxima and its minima almost coincide with the maxima and minima in the number of spots. Now, it's a good trend. That is to say, we could build a scatter plot. You know, we put one on the y-axis and one on the x-axis, and we plot a line between them. Like, what's the relationship between the number of sunspots and the amount of solar radiation? Lo and behold, there's almost a one-to-one relationship. It's pretty good, and we have pretty good data going to back that up. So, in the current study, published in 3 peer-reviewed papers, and I have to tell you, Earth Explorers, I don't have a lot of confidence in peer-reviewed papers. That's why I read stuff myself and analyze it myself. And as a professional and acting statistician, sometimes I can tell, you know what, these statistics are bullshit. But the researchers analyzed a total background magnetic field from a full disk of magnetograms for 3 whole cycles of solar activity. This is 21 to 23, by applying the so-called principal component analysis. And what this does, it reduces the data dimensionally and the noise and identifies waves with the largest contribution to the observational data. It sort of drops the floor out of it, and we start looking at the nodes of it, the peaks of the waves. And the waves, we take the full width and half height, and that gives us a mass amount of data that's pretty reliable. Put it this way, the data that's in that analysis, if it's in it, it's very clear. If it's outside of it, it is almost insignificant. Anyway, this method can be compared to the decomposition of white light on the rainbow prism, revealing waves of different frequencies, like when you use a prism. And as a result, the researchers developed a new method of analysis, and it helps us uncover that the sun's magnetic waves are generated in pairs, with the main pair covering 40% of the variance of the data, and the principal component pair is responsible for the variations of a dipole field of the sun, which is changing its polarity from pole to pole, as I said, during this 11-year cycle. The North Pole becomes the South Pole becomes the North Pole. Does the sun actually roll over? No. Physically, it doesn't change. But magnetically, it does change. Kind of leads us to believe that there's some kind of core in the middle of the sun that is either rolling over, and thus the rotation inside this motor that we call the sun reverses, and that's why we see this pole shift. But 11 years is pretty dynamic, isn't it? It's not like a pole shift of the Earth every 100,000 years. And the magnetic waves travel to the northern hemisphere or to the southern hemisphere of the sun, with phase shift between the waves increasing with a cycle number. And the waves interact with each other in the hemisphere where they have maximum, northern for odd cycles, southerns for even ones, and 2 components are assumed to originate in 2 different layers in the solar interior with close but not equal frequencies and a variable phase shift. And this is all pretty recent data, going back only to 2013, but it's a good analysis, I think. And the scientists derive the analytical formula describing the evolution of these two waves and calculating the summary curve linked to the variations of sunspot numbers. So to clear this up, the original proxy of solar activity, when using the modulus in the summary curve, by using this formula, scientists have made predictions. And this is why models are so valuable when they're repeatable and when they're reliable. That is to say, when some other scientist can make independent observations and come up with the same conclusion. That's what we mean by repeatable and reliable. The scientists made predictions of magnetic activity in solar cycle 24, which is the cycle we're wrapping up right now. And guess what the confidence interval was? Oh, it wasn't 90%. It wasn't even 95%. It was 97%. That's very good. 97% confidence interval in comparison with the principal components derived from the observations. Now, if you look at the NOAA's data, that would be the people that say that we're causing global warming, that human activity is responsible for everything, and we must pay for it. The confidence interval that they report in their own papers, and I'm not going to read them, but I will tell you, the confidence interval they report in their own papers is 38%. 38%. That is not good. That's like no correlation at all. We like to see 90, 92, 95, 97, 98's great. 38, that means 62% of the data that they collected themselves shows global warming is not man-made. But they don't report that. They don't report that. Old Nadlis, he waves around his paper, and OAA says 38% confidence that, wait a minute, do you realize what you're saying there, Nadlis? You know, get your pants down around underneath your nipples where you can breathe a little bit, okay? It means 62% not correlating. Yeah. Anyway, inspired by this success, the authors extended the prediction of these two magnetic waves to the next two solar cycles. That makes sense, right? Solar cycle 25, solar cycle 26. Both of those are about 22 years, right? 11, 11, 22, 11, 11, 22. And here's what they discovered. They discovered that the waves, they become fully separated into opposite hemispheres in cycle 26, and thus have little chance of interacting and producing sunspot numbers. You know what that means? Without sunspots, the solar radiation drops. Solar radiation drops. You remember, I told you, from 1650-ish to 1700, there were 50 sunspots instead of like the normal 50,000 sunspots. And during that period, very little infrared and cosmic radiation came to the Earth. That means it didn't strike the ground. It didn't warm the water. It didn't warm the planet. The planet began to emit its energy into space, which it does all the time anyway, but it wasn't being refilled. It was just driving and driving and driving and driving, and nobody was putting any fuel in the tank. And it doesn't take long. 1 or 2 or possibly 3 winters, and you're in it. You're in it. So solar cycle 26, little chance of interacting and producing sunspot numbers. And you know what this is going to do? Everybody's model shows it. Not the meteorologists. Forget about those guys. They don't believe in mathematics. This is going to lead to a sharp decline in solar activity during the years 2030 to 2040. Doesn't that ring a bell to you? The 2030 agenda? Do you know what this means? Well, I'm going to tell you what it means in a minute. But you compare it with the conditions that existed during the previous Maunder minimum in the 17th century, right? When there were only about 50 to 70 sunspots observed instead of the normal 40 to 50,000, right? You know what happened. The new reduction of the solar activity is going to lead to a reduction in the solar irradiance by a lot. I mean, it's about 3 watts per square meter, which is huge. According to the data, this previously resulted in significant cooling, not warming, of the Earth and very severe winters and cold summers, just like we've been seeing. Okay, now it got hot this summer in LA, but it didn't last. And it has been cold as you know what since before Thanksgiving. And this is the second cold February in 3 years. Several studies have shown that the Maunder minimum coincided with the coldest phase of global cooling, which was called the Little Ice Age. And during this period, by the way, the Thames River froze solid, bank to bank, froze solid. It has happened since then, recently. Let's see. During this period, there were cold winters in Europe, cold winters in North America. In the days of the Maunder minimum, the water in the Thames and the Danube froze all the way across. They had dwellings like dance halls and stuff like this built on the ice on the river. That's how reliable it was. Let's see. The Moscow River was covered with ice every 6 months. Snow lay on some plains year-round. That means it didn't melt in the summer. It snowed on the old snow from the previous year. Greenland was covered in glaciers. Dr. Helen Popova, who developed a unique physical mathematical model of the evolution of the magnetic activity of the sun and used it to derive the patterns of occurrence of global minima of solar activity and gave them a physical interpretation. If a similar reduction is observed, you know what's going to happen. This data does not lie. During the upcoming Maunder minimum, this can lead to a similar cooling of the Earth's atmosphere. If it does, what's going to happen is the Earth's albedo, that is to say, the amount of the sun's radiation that the Earth radiates back out into space, is going to go up. And if the existing theories about the impact of solar activity on the climate are true, and I believe they are, that's what I've been talking about here for half a dozen years, then this minimum will lead to a significant cooling. However, to the one that occurred during the Maunder minimum, it remains to be seen, because we have a lot better forms of energy now than we did in the 17th century. We don't have to burn wood. We have electricity. And so we, as a race, can survive it a lot easier if we reapportion our energy. And time is only going to tell, but, it isn't going to be much time. Like it's 2023 now. Sorry, I'm a time traveler, so it's hard for me to remember years from time to time. 15 years to maybe down to as close as 5 years. 5 years is not much. I mean, at my age, 5 years is like 5 months because they reduce years as you get older. You'll find that out. Given that our future minimum will last for at least 3 solar cycles, which is about 30 years, it is possible that the lowering of the temperature will not be as deep as during the Maunder minimum, but we are going to have to examine it in detail. We keep in touch with climatologists from different countries. We plan to work in this direction. Of course, they're pushing in an opposite direction because they believe that global warming is directly tied to the amount of tax money they can extract from it.